Yes, we are in live. Kabisha, you can start.
Yes. A very good morning to all the participants. It is a great pleasure to have you all here for this Knowledge 4.0 webinar series, which is one of the unique initiative of Chennai Institute of Technology under the guidance of our Honorable Chairman, Shri P. Sriram, a successful first-generation entrepreneur, a well-known industrialist, and managing director of MK Group of Companies. Chennai Institute of Technology always keep the door of learning open even during this pandemic situation by conducting Knowledge 4.0 webinar series, technical workshop seminars, short-term training programs, faculty development programs, conferences where eminent speakers from academic institutions and industry conferences where they give deliver the recent advancements and technologies in engineering domains. Chennai Institute of Technology was established in the year 2010 by our Honorable Chairman Sri P. Sriram, and now our institute is being ranked within top 10 institutes among private engineering colleges in Tamil Nadu. Now, we are happy to welcome you all for this one-week faculty development program on emerging technology trends in fourth industrial revolution world. We request Dr. B. Dhanalakshmi, Associate Professor of Department of Computer Science and Engineering, Chennai Institute of Technology, to give the welcome address.
Thank you, Kabisha. Welcome you all participants and welcome our chief guest, Ms. Sarita Digumarti and Dr. Amit. And, uh, and today's FTP topic, emerging technologies. So emerging technologies can be powerful agents for any good cause. And fourth industrial revolution has the power to change the world positively. And in the future, it can also change the things we value and the way we value them. And there is a necessity for every individual to compete the growing power of technology. And this one-week faculty development program on emerging technology trends in fourth industrial revolution world with the theme of cloud computing, artificial intelligence, machine learning, deep learning, data science, and data analytics will definitely bring a transformation towards the emerging technology breakthroughs. On behalf of Chennai Institute of Technology, we welcome you all and our chief guest, Ms. Sarita Digumarti, Head of Academics and COO of Jigsaw Academy, for this faculty development program. And we hope this event will definitely help you grow to be more productive and smart in emerging technology trends. Now over to
Thank
you,
you, ma'am.
Kabisha.
Thank you, ma'am. Now we welcome Dr. Ramesh Dean, Chennai Institute of Technology, to give the opening remarks for the event.
Yeah. Good morning to all. On my behalf, I extend a very happy welcome to all the participants for this FDP on emerging technology trends in fourth industrial revolution world. At the outset, I would like to express my sincere appreciation to the Department of Computer Science and Engineering of Chennai Institute of Technology for having selected a wonderful topic for the faculty development program. I understand many faculty members and also students and others working in industries are attending this particular FDP. Being a faculty, we need to continuously upgrade our skills and knowledge so that we can transfer those knowledge and skill to our student community. So for that, we need to continuously update the technological development that are taking place in our field of specialization. So it may not be possible for us to learn this technology on our own by reading some books or by listening to some videos. Rather than if we participate in this type of FDP, wherein the leaders or experts in those technology will be interacting with you, which will help you to gain maximum knowledge in that particular area. So now everybody is talking about the industry 4.0. So just to give a brief introduction about this industry 4.0. So in fact, after the civilization, the industrialization have started after the invention of steam engine. Only after the invention of steam engine, lot of industries have started their operation and many goods or products have been manufactured. Those scenario were termed as industry 1.0. So at that time, parallelly, the population also have started to grow up across the globe. So the need have been at that time the need was to make the product in a big volume. So the concept of mass production were introduced at that time. So Japanese were pioneer in at that time, and that scenario was termed as Industry 2.0. Along with mass production, so many quality control tools, quality control techniques, everybody has everything have started to come into play during that Industries 2.0. As I said, Japanese have taken a lot of advantage in that 2.0. Later on, slowly people have started to automate the things. So automate the machinery, automate the manufacturing processes, automate the quality control. So automation slowly get into play after the technology development that has taken place in the field of computers and networking. So slowly the entire industry have started to implement the automation technology in their industry, and that time it was termed as Industry 3.0. So that has led to lot of business advantages to the companies. They were able to launch the product at the quickest possible time and also at the lower cost. So that was the advantage gained by the Industry 3.0. Now we are living in the Industry 4.0, wherein in the automation, so many components have started to contribute for the Industry 3.0, like sensors, the so many transducers, some kits, so many things, IoT components, embedded kits, like that. So many components have started to help to improve the automation. Now, these in the industry automation, Industry 3.0, these components have worked independently. Now, the time has come that the component has to interact with each other, and they have to take their decision on their own without depending on human. So that led to the development of Industry 4.0. So for the success of this Industry 4.0, parallelly so many technologies have started to develop, and these technologies are called as disruptive technology. Normally, whenever a technology is evolved, that can be grouped in any one of two types. One is called as sustainable technology development, and another one is a disruptive technology development. So for the Industry 4.0, the disruptive technology development are playing a major role in improving the efficiency and as well as success of the Industry 4.0. So when I say the disruptive technology, I think all the topics are going to be discussed in this particular FDP, like your machine learning, artificial intelligence, deep learning, cloud computing, IoT. So many technologies are there. So being a faculty, every one of us should know about what about this technology and how this technology is being implemented in this Industry 4.0 scenario. So that we can transfer those knowledge to our student community, so which will help in a big way for our students to improve their knowledge and skill. So here nowadays the companies have started to look for skill-based placements. The days are gone wherein the companies have started have looked only some basic knowledge about programming or some basic knowledge about coding and all. But now the days are gone, and now the companies have started to look into an engineer who is capable, who is having knowledge in multidisciplinary. So this disruptive technology is not only essential for computer science and engineering graduates or faculty. In fact, this is very much essential for almost all branches of engineering. Yes, mechanical engineer also should know about what is machine learning, because machine learning is a concept, but the application mainly lies with a lot of mechanical engineering application. Even a communication engineer, electrical engineer, they should know about the machine learning because they are working with the grid computing, grid everything. So like that, this particular technology, all the engineers should know about this technology, and they can apply this technology in their field for their own application. So by this way, I know that this particular FTB is going to help all the participants in a very big way to update their knowledge in the latest technology which are currently used in the industry. So I take this opportunity to request all the participants to interact with the experts, because the Department of Computer Science and Engineering have taken a lot of what I can say that the effort in bringing in leading experts in every field. So they are giants. So they have a very wide practical knowledge in all these disruptive technologies. So please interact with all of them. Try to take more advantage of attending this particular FDP. I wish this FDP a great success, not only for the Chennai Institute of Technology, but for all the participants who are taking keen part in this FDP. Thanks for the opportunity.
Thank you, sir. So now we take immense pleasure in welcoming our chief guest, Ms.Sarita Digumarti, who is the head of academics and CEO of Jigsaw Academy, a Manipal global education industry company. She has been over 20 years of extensive analytics and consulting experience across diverse domains, including retail, healthcare, and financial services. Her experience spans companies like Symphony Marketing Solution and Chimpat LLC. As an educator, she has designed, created, and delivered programs across analytics, data science, and machine learning landscape. She has facilitated several technical programs for seniors and mid-level teams in companies like Tesco, Diageo, ICICI Bank, Society General, and more. She has masters in quantitative economics from Tufts University and an MBA in finance from TAPI Management Institute. She has been rated as one of the India's top 10 data scientists. We request our chief guest for inaugural address for the participants. We welcome you, ma'am.
Thank you so much. Hello, everyone. Very glad to be part of this faculty development program. And thank you so much for inviting me. And the topic of my talk is to sort of get the program kick-started, talking about emerging trends in Industry 4.0. So I'm going to share my screen, and you know I'm going to spend about 15 minutes or so walking through the presentation, and then I'm happy to take questions. As I was introduced, you know, just a little bit more context on my background. My background has been mostly around quantitative consulting and analytics. So I've been doing data science for a very long time. And of course, data science includes, you know, machine learning, some applications of AI, and so on. So I have some understanding of that space. And of course, at Jigsaw Academy, you know, my primary responsibility has been in developing content and teaching material and sort of, you know, creating programs to help students pick up data science and emerging technology skills. And I think, as you know, Dr. Ramesh said earlier, it's very important to understand now that, you know, it's not enough to sort of be conceptually strong, right? Companies, you know, are looking for people who can apply and who can apply a variety of skills. And that, I think, is something that we will see in my presentation as well. When I talk about trends in Industry 4.0, I think the main thing that will come through is the fact that we are talking about technologies that are multidisciplinary. And therefore, it becomes very important for all of us to make sure that we are keeping up with the trends. But more importantly, we are thinking about how to apply things in a multidisciplinary manner. So that's broadly what I want to talk about. Let me just share my screen, and I will share my presentation. Please feel free to ask any questions. I'm happy to answer. I will take a look at the chat window once I go through the presentation. I'm happy to answer questions. Just to provide context for Industry 4.0, right? And again, as was earlier mentioned in today, there is this idea of, you know, industrialization that really started with Industry 1.0 with the early use of power from steam and water, right? And that really transformed economies across the globe, because, you know, suddenly people were moving from you know, doing primarily agricultural based work to, you know, to sort of the factory sort of system, you know, where you're using power to be able to, you know, to be able to generate a lot more output than you were able to previously, right? 1.0 led to 2.0, primarily with this mass production, especially you know, with Ford, you know, which introduced this idea of a factory floor and, you know, the division of labor, and therefore efficiencies generated from division of labor and electricity, right? The ability to use electricity to mass produce things. That was in the early 19th century. I think post World War II, as was specified, there was an Industry 3.0, which was the heavy use of computing and automation again to sort of radically transform the kind of output that was being generated from industries across the globe. So that's broadly the context. I think in 2015 this Industry 4.0 term was formulated, and the idea of 4.0 is primarily linked to this thought of connecting, everything connected to everything, right? Which is this whole idea of Internet of Everything or Internet of Things, where now the machines are connected to each other, and that there is a lot more efficiency and throughput and output that can be generated because you are able to get machines to sort of share data and talk to each other, and therefore be able to maybe make some decisions on the fly, and requiring less and less human intervention. So that's the idea of Industry 4.0. Is it a revolution? I certainly think it is. Is it going to transform how products are made, how services are designed in the next 10, 15, 20 years? Absolutely. But when we talk about Industry 4.0, obviously that's a fairly large term, right? What does it actually involve? So this, this slide is from one study that that was conducted that talked to a lot of enterprises, medium and large enterprises, and try to get at what are the trends that people foresee in Industry 4.0 specifically for 2020 and beyond, right? And so you can see a lot of these here, starting with artificial intelligence, edge, fog and cloud computing, robotics, Internet of Things, augmented reality, network connectivity, big data and analytics, 3D printing, security, transparency and privacy, and digital twin. And the percentages are essentially the percentage of respondents that felt like these were very important and critical trends for Industry 4.0 to work, right? And so what I'll do is I'll spend a little bit of time on each of these, and then we can sort of talk about what does that really involve. So let's start with AI, right? AI, everybody gets excited with the idea of AI, right? This idea that there is that you can get things done without absolutely needing any human intervention, right? The ability for machines to make decisions that a human would do, and that is our holy grail for AI. Now, AI, of course, there is a lot of hype around AI, and also I think there is a lot of misleading nomenclature and terminology around AI. What used to be called data science is now called machine. In fact, what used to be called analytics is now called data science. What was data science is now called machine learning. What is machine learning is now called AI. But in AI, one of the things that we have to understand is that if you are going to try and replace a human's thinking process or a human's decision making process, humans make decisions on the basis of multiple inputs, right? Multiple contexts. So if you think about how we make decisions, of course, we look at the information that we have, and we sort of process that information. Reasoning that we use to process that information, it includes a lot of different kinds of reasoning. So for example, it could be quantitative, it could be qualitative, it could be creative, it could be ethical, it could be cultural, and many of these, the inputs into the decision making process are also subconscious. So the idea of getting to AI, I think there is a lot of work that is being done, and this is going to be something that's very, very critical. But right now we are still a long way from there, because most AI systems, if you think about it, tend to be very narrow focused AI, what is called narrow AI, right? Not general AI. So for example, if you look at something like a chatbot, right, where or natural language processing, machines like Siri or Alexa do a great job of taking one input, which is audio or text, and sort of making sense of that. And while they get better and better at it, true AI is going to be when they're able to combine audio plus video plus other inputs, and we really make global decisions. But like I said, there is a lot of progress here, and I think AI is going to be something that that is going to be exciting to a lot of people and interesting to a lot of people. Another big trend is augmented reality, right? We have augmented reality in terms of, virtual reality or augmented reality or mixed reality. And the idea is, can you superimpose additional information on top of, let's say, in augmented reality, if you're looking at an image of, let's say, a famous monument, can you sort of very quickly, for example, using Google Lens, be able to figure out, interesting information about that monument? Or can you create virtual worlds? And this is even more interesting, especially now when we are in the middle of this pandemic, where suddenly we are not meeting physically. But everyone understands that the importance of peer-to-peer interaction is very important when it comes to whether it is studying in a classroom or you're working at office. And so these virtual reality environments, which essentially enable people to have the feeling of being in a single space, are going to become very important. Lots of applications for augmented reality, virtual reality. It's not just not just entertainment. Though entertainment is of course very large, gaming and all of that, but also, for example, in retail, in healthcare, lots of really interesting applications for AR VR, which is going to become more and more interesting. Again, for AR VR systems to work, for AI to work, and I'm specifying this again, remember that there is a hardware angle, an engineering angle, and a software angle, and a data angle, right? A lot of these systems require many such inputs to sort of work together for a truly VR system or for a truly AI system. The third very important critical sort of trend for the fourth industrial revolution is this idea of cloud computing, and of course edge computing, right? Edge computing is this idea of doing computing at the as close to the data collection as possible. So things like automated sensor controls, etc., embedded automation controllers. The idea is that you don't take the data, send it to a server, and then you sort of do the processing and then you send the data back, because many times for AI systems, etc., you need the decision making to be as real time as possible. So how can you sort of build in the compute power at the edge as much as possible? And of course, if you need to be doing much more hardcore processing across multiple layers, then you sort of think about cloud computing, that you're not restricted by physical infrastructure. You have the ability to access your data from anywhere. You have the ability to apply extremely large and powerful algorithms to your data that you're collecting from multiple sources. There is a lot of excitement and work now within cloud computing and edge computing. We see that, again, very multidisciplinary. A lot of people who work with data now need to understand how cloud works. A lot of people who work with engineering now need to understand how cloud networks work. And again, very important, and a very strong enabler for Industry 4.0, right? The fourth thing is very important, is networking and connectivity, which is this idea of 5G. Everyone's excited about 5G, and 5G, is supposed to be extremely reliable. It's supposed to be, low latency. It's supposed to have very high bandwidth. It can support a massive number of devices. And again, as you can see, for the sort of the technology and the applications that we are building, this is going to become extremely important, right? The ability to have enhanced mobile broadband, to have very reliable and low latency communications, going to be very critical, right? Whether it is things like augmented reality, or you're talking about self-driving cars, or you're talking about for example, automation, in Industry 4.0, or smart factories 4.0. This ability to make sure that your network and connectivity is super reliable is going to become very important, right? And again, a lot of work here, and a lot of companies expect massive transformation because of 5G. Another very interesting trend is around robotics, right? And we've all seen, I'm sure, videos of very human-looking robots. There is Sophia, which was built to sort of look like a human being, had the ability to make conversation. With Boston Dynamics, for example, they make these very flexible robots, right? That can walk and sort of really mimic a lot of human movement range, and again, a lot of interesting applications, right? With robotics, a lot of people worry that having robots will replace humans, and that eventually all jobs are going to go away because of robots. Again, I think that is limited thinking. I think there are a lot of applications of robotics that essentially help humans not be in dangerous jobs or dull and repetitive jobs. For example, if you need someone to go down mines, right? And we still in the current 21st century have accidents where people go down mines and then they get trapped and they die, which is such a loss of life. You can have robots that essentially can take over from humans in very dangerous situations, right? Or if you have dull and repetitive jobs, for example, stocking in a warehouse, right? With the scale of e-commerce, where all of us are increasingly going online to sort of order items, And again, the pandemic has, I think, absolutely dramatically increased people's reliance on e-commerce, because it's in some sense contactless, it's hassle free. So then your supply chains are getting much more complex. Your warehouses are getting very, very large, and the efficiency with which a robot can, for example, stock things in a warehouse or even retrieve things in a warehouse, for 12 hours at a stretch or 14 hours at a stretch, is not something that a human being can hope to match. And also, is that value add for a human being, right? Those working conditions and that dull repetitive work. So I think a lot of we are going to see a lot of robots sort of help humans perform tasks that are either dangerous or that are very repetitive. And I think we are going to see, my opinion is that robotics is something that we are going to see a huge amount of action in the next 4 to 5 years. I think this is something that's going to be very important. Big data and analytics, and of course this is my favorite slide, because I come from an analytics background, and so I strongly believe that the data is the brain, right? The data is the key. And one of the things that has happened is that people tend to think that analytics or data science or machine learning is new, but I'm sure, as all of you know as faculty, right, machine learning algorithms, these statistical algorithms have existed for a very long time. What has changed is data, right? For a machine learning algorithm to work, you need lots and lots of data, right? The more data you feed it, the more patterns it is able to sort of generate, the more it is able to figure out which are robust patterns, the more it's able to come up with predictions basis the pattern in the data. So the amount of data that is available is something that has changed dramatically in the last 5-10 years. When I started my career in data science, it was a very niche area. It was supposed to be highly specialized. There were very few data science per se jobs in the industry, right? But now the situation is very, very different, right? Because everybody needs data skills, because everybody has access to data. Everybody has access to data because we are generating and we are capturing and we are collecting a lot more data. But more importantly, the ability to store this data has become very, very easy, because the cost of storage has reduced dramatically, right? That has been a key enabler of the analytics and the data science revolution, which is the cost of storage. We are able to store data very, very cheaply. Most companies don't need to think twice about the kind of data that they store. And of course, the second thing that has happened is computing power, right? It's become easier and easier to now sort of for anybody to have the ability to do things that only a supercomputer could do 20-25 years ago, right? A lot of algorithm, a lot of software is free, it's open source. So all of us have access, and if we have the skills, we will have the ability to make sense of data. So that is really that's been a key part of the transformation of how data is being used in industry. And for industry 4.0, if you think about it, right, earlier without data there were no data-based answers, right? But now, if you think about traditional analytics, right, there were some traditional answers and you would get some, there were some traditional questions and you would get some traditional answers, right? Which is what is in point one here, old answers to old questions, right? As you apply advanced analytics, then you are able to do new answers to old questions, but you're still basically, focusing on advanced analytics, which is machine learning. Now, when you have big data, right, if you apply traditional analytics, you can potentially with machine learning algorithms find newer patterns, newer relationships that you are not able to find from a statistical model. And while you may not be able to explain what is causing that, what is that relationship, you have the confidence that, okay, this pattern essentially means, if A, then B, right? Which is the new answers to old questions. And if you apply advanced deep learning, machine learning algorithms now to big data, you not only have new questions, but you have new answers, right? And that, I think that is very, very key. I think a lot of people understand that, when you have access to this much data, big data, right, and a variety of data, which is also very important to understand. It's not just quantitative data, but a lot of qualitative data, audio data, video data, text data. And when you can put all of that together, the amount of information that you can generate from those data is going to be humongous. And I think therefore data is absolutely going to be key to the industry 4.0, and the ability to make sense of data is again going to become very critical for everybody. Like I said, analytics or machine learning, yes, it is a concept, but anyone building a new product or a new service has to think about, how do I make sure that I'm leveraging data to make sure that my product and my service continues to be useful, that it's people, that I'm getting information on usage, that I'm using that data to make improvements in my products and services. So it's going to become very, very critical. Internet of Things, right? This is a great example. Someone made an internet of cows, right? At some point in Scotland, people attached sensors to a herd of cows. And essentially those sensors, check temperature. They were able to figure out location of the cows. And essentially, using the data, the farmer could sort of figure out when the cow was ready to be milked. They could figure out where these cows were, where the calves were. So this idea of connecting things, connecting machines, right? Here's another example. This is, from our coronavirus, situation handling, which is, thermometers, digital thermometers that are location enabled, right? And people can use this to sort of figure out where patients are, create maps of patients across a very large part of the country, and sort of use this very effectively to be able to do tracking, to be able to come up with containment strategies, to be able to really manage pandemics, right? And this, again, very, very critical, right? It's a foundational aspect of Industry 4.0, the ability for machines to communicate with each other, which is essentially this machine-to-machine communication, right? And a lot of exciting work. IoT is something that people have been expecting great results from for the last 5-6 years. It's gotten off to a slow start, but I don't think that there is any doubt that this is going to become very, very critical. The ability for machines to have sensors, to collect data, to be able to then do some quick computing using that data on the edge, to be able to sort of really come up with the refinements of what needs to be done on the basis of machine to machine data, I think is going to be very, very important. 3D printing is another, I think, extremely important trend, also called additive manufacturing, which is this idea of building, building things layer by layer. Again, very, very important. A lot of very interesting outcomes are coming up. People are printing, there's 3D printing applications in healthcare where people are able to come up with even organs using 3D printing. But of course, a lot of, factory floor, products, 3D printing is going to become very important. Again, very exciting and very interesting. Cyber security, right? This is very important. Again, I think like data, cyber security is also a very, very critical aspect for the success of Industry 4.0 to work, right? In some sense, it is almost a prerequisite for this industry, right? Because when we are talking about connected systems, then you have to think about security, you have to think about privacy, and all of this has to be taken seriously, right? And as the connections become more and more sophisticated, as the kind of data processing we do becomes more and more sophisticated, the impact of attacks also become very, very high, right? Cyber security attacks are also keeping pace with with sort of new developments, right? There's a lot of people who apply machine learning, deep learning sort of techniques around coming up with cybersecurity hacks. So very, very important, and to make sure that your systems are resilient, that your systems are vigilant, that your systems are secure at such a large scale requires a lot of work. In India, especially, we are very vulnerable. I think cybersecurity is one area where we have not really, let's say, come up to speed as much as the rest of the world. We are increasingly going digital, and it is a ticking time bomb, right? This is something that I think in India, especially, we need to be investing a lot more in than we are currently. And then this final idea of what is called a digital twin, which is essentially simulations at a large scale, right? The ability to sort of come up with a digital simulation of whatever product or service that you are sort of creating, that can help you test, that can help you test hypotheses, test physical properties. And I think the simulation idea has been extended to sort of really to sort of have this interaction with the physical world, right? So you can have simulations or digital twins not only of, let's say, a product that you're planning to create, but also of services, of organizations, of factory floors, right? And the ability for you to sort of then test and assess risk before you go into production becomes very, very important. And again, I think a very exciting sort of trend in simulations, and this is something that's also going to become very important. So those were broadly the trends that that were in that first slide that talked about Industry 4.0. I want to show you a couple of examples. Some of them may be a little extreme, but things to think about, right? Essentially, what are called tipping point technologies, right? The point at which a technology could have, we can say that has really, moved from small, small, innovative, or interesting impact to something that is larger and more important, right? So, for example, we think that 1 trillion sensors will be connected to the internet by 2022, right? Which is, think about it, every single mechanical, electrical device that you are working with will probably have a sensor, right? Starting from the switches in our house to our cars to our phones, everything will have a sensor, right? 10% of global citizens will be wearing internet-enabled clothes by 2022. And some of these years here are predictions, so it may not be 2022, maybe it's 2023. But think about it, right? Designers are already talking about clothes that have sensors in them, right? Clothes that can tell you if you're feeling too hot, if you're feeling too cold, things like that. So, our clothing itself may become internet-enabled by 2022. We may have the first 3D printed car by 2022, right? Again, if 3D printers can print organs that we can use for transplants, I think, much before that, we will have 3D printed cars that will be in production, right? Implantable mobile phones, right? All of us are so used, I think, now to holding the mobile phone in our hands, right? Many of us, now miss it. If 5 minutes goes by without us looking at the phone, I think that's a big thing. A lot of us are addicted to our phones. But if you think about it, it is physically uncomfortable to hold something else in your hand, right? I personally think that that these devices are going to become implantable and possibly commercially available by 2025, right? 10% of reading classes will be connected to the internet by 2023. It's quite possible that there's a lot of augmented reality applications that you can think of while you're reading to be able to add additional information. Interesting application. 80% of people will have a digital online presence by 2023. I think we all know this is bound to happen. 3D printed liver by 2024, possibly. Again, groundbreaking stuff in terms of technology here. The ability to print organs on demand. Think about the implications that it will have. No more trafficking. No more long wait lines for people that need transplants. This will really revolutionize the healthcare industry, right? 50% of internet traffic will be for home automation. Our TVs, our blenders, our coffee machines, our washing machines, all will be connected to the internet. There are already applications in Amazon in the US where you can use Echo and you can sort of assess that you're going down, for example, on washing powder, and then you can automatically place that order, and your fridge will be able to place orders directly from the internet very quickly. So again, very interesting applications for home automation, right? 30% of corporate audits will be performed by artificial intelligence by 2025, right? This is very interesting, right? This idea of audits, right? In auditing, essentially what people need to do is go through lots and lots of documentation and make sure that what information they're finding in the documentation is linked to rules and is okay basis the rules that are required from a financial perspective. And certainly this is the kind of repetitive work or work that I think will be very, very open for automation, right? That humans will then intervene when they see an issue, when they see that there is a deviation, when they see that there is a problem. But otherwise, the ability to go through a lot of documentation, figure out relevant information, compare that to a rule, something that I think will very easily be done by automation systems very quickly. Driverless cars possibly account for 10% of all cars in the US by 2026. Again, a lot of experiments have already happened. A lot of progress on driverless cars. A lot of buses within campuses now are driverless, and I think this is definitely something that we are going to see fairly quickly. That that there will be a commercially viable driverless car. That people are going to be able to buy and going to be able to use fairly quickly. The first AI machine will join a corporate board of directors by 2026, possibly. This may be, I think, a little bit of a stretch because there are some ethical concerns as well. But AI systems to be used for governance, to be used for audits, to be used for a lot of the corporate governance sort of work that is done. I think that is something that we will definitely see happen very often. First city with no traffic lights will be here by 2026, possibly. You really don't need traffic lights if everything is connected and you are able to control traffic, much better with real-time decision making. So possibly that's also something that can happen. So the examples I gave you were, essentially just to hopefully make you think about, the kind of transformation that we can expect from Industry 4.0. I want to end with this slide, which I think is very, very important, especially from when we're thinking about how we prepare ourselves for Industry 4.0. All of us, faculty, students, people who work, everyone is living in a very, very what we call a VUCA world, right? Volatile, the nature and dynamics of change, the nature and speed of change forces and change catalysts, very volatile, right? Uncertain, there is a much less predictability, much higher ability to be impacted by surprises. And again, the coronavirus epidemic is a great example, something that came out of nowhere and has had such a massive impact on every single person's lives on this planet, right? A lot of ambiguity. It's much harder now to sort of figure out, A or B. A lot more mixed meanings and a lot of cause and effect confusion and complexity, right? There are multiple forces, there are a lot of linkages, there are a lot of confounding of issues, and a lot of chaos and confusion, right? We are all living in sort of a VUCA world, and therefore it becomes very important for us to focus on these things, which is vision, right? Understanding, which is, I think, the main focus of the faculty development program, is for us to be able to understand new tech, new trends, new behavior in the world, because without that understanding we will not have clarity, and without that clarity we will not have the ability to react, to respond, to sort of manage the situation. So this, I think, becomes very, very important. The understanding that all of us are living in a world that is changing very fast, a world that is technologically, making massive advances on almost a daily basis. And so it becomes very important for us to sort of understand these trends, understand the impacts, understand the implications, and sort of then use them to be able to provide purpose and, the way forward for ourselves and for our students. So thank you all. That was my presentation on Industry 4.0. I'm happy to take any questions.
Yes, ma'am. We have questions from Dr. Maniraj.
Okay.
How AI and data science helps in product development?
Great question. So I think a lot of data analytics traditionally has been in support of services, and that a lot of my experience has also been that, right? In sort of services related to products. So, for example, how do I market the product better using data? How do I identify customers better? But if you think about product development, right? Think about something like an Uber or an Airbnb, right? These are companies that have created products on the basis of data, right? The ability to sort of, and I'll give you another great example, right? And this is a very favorite example of mine because I've lived through this evolution. Think about Netflix, right? I used to live in the US many years ago, 20 years ago. And when I lived in the US, Netflix was a DVD rental company, right? Essentially what you would do, you would go online, you would find a movie you like, you would order it, they would send a DVD to you by mail, you would view the movie and you would return it back, right? It was a DVD rental company. But what is Netflix now? Is it just a streaming provider? It is more than a streaming provider, right? What Netflix has become is that they have become a content creator, right? So think about content creation for movies, for entertainment, right? It is very, very expensive. It takes a lot of money, it takes a lot of time, and then at the end of it, you don't know whether that movie is going to be a hit or not, right? But Netflix was able to really completely transform itself from being a DVD rental company, from being a third party content streaming provider, to somebody who created content on the basis of analytics. Because what they realized was that they had data on people's preferences. They knew, for example, that, okay, people, let's say males between the ages of 25 to 35, like these kind of movies, they like these kind of plots, they like these kind of actors, they really like this director. And essentially they built, the first content that they created was House of Cards, which was a massive hit, right? but they were able to invest in creating that series because they had data, and they were confident that if they, for example, included Kevin Spacey and they included that particular director and they included a political show, that they were fairly confident that it was going to be a hit. So that's essentially how data is used to create products, right? Because now you have understanding of what consumer preferences are, what are people willing to pay for, what features will they show interest in, and you are able to therefore put in all of this information together to create a product. And you can also very quickly test, right? As you create the product, you can also test people's reaction to the product using data, and you can do this at scale. So very, very important now. We are living in a world where all of us are demanding personalization, right? Earlier, it was one size fits all, right? But now, for example, I want to see ads that are only interesting to me. If I like going to the beach on vacation, then I don't want to see ads about going to Kashmir, right? And all of us are increasingly demanding it, and therefore our products and services that we consume are becoming personalized, and that is happening on the basis of data.
So we'll take up one more question, ma'am. In small or medium scale industries, how can we start the implementation of Industry 4.0 concept? Can you share some practical point of view?
Yeah. So I will come back to my earlier point about the cost of a lot of this tech has become very, very reasonable, right? I think the earlier the barriers to entry used to be very high, right? The cost of this technology, there was very little development, let's say, locally, and therefore the adoption of this technology used to come with high barriers of entry. I think one of the things that has been demonstrated, I think, is that there has been some democratization of this, not just of data but also of technology, and I think the ability for even small or medium enterprises to adopt many cutting edge technologies is actually a lot easier. And now there are a lot of product as a service models where you don't really need a lot of upfront investment to be able to do this. And I think this is something that small and medium enterprises are realizing fairly quickly. When I started my company about 10 years ago, the landscape was very different. And we work with a lot of startups. We work with a lot of entrepreneurs who have small and medium size enterprises, who come to us because they want to understand technology better, who want to understand how to leverage data better. And you can see in new startups now, in new companies that are being set up, people are already thinking about how do I leverage technology and how can I do this cheaply. And there are, I think, plenty of opportunities now for you to be able to leverage this at very minimum cost.
Yes. So we are very happy and honored to have you here, ma'am, for the inaugural session. On behalf of Chennai Institute of Technology, we thank you for making time in a busy schedule and accepting our request to join the event today. And your presentation will definitely make us to know the breakthroughs in emerging technology trends. And I take this opportunity to express a heartfelt gratitude, and we hope to connect with you in future as well. Thank you, ma'am.
Thank you so much. I'm very happy to be here. Thank you for inviting me. If anyone has other questions, I'm happy to answer them. You may please email me, and I'm happy to answer. And good luck for the faculty development program.
Thank you, ma'am. Thank you very much.
Thank you.
Now we have a speaker for the next session. Over to you, Kabisha.
It is a great honor for me to introduce and welcome our speaker for the session, Mr. Selvakumar Kamalanathan, Assistant Professor, National Institute of Technology. Now I request Dr. Dhanalakshmi ma'am to introduce our speaker.
Uh, so I'm very honored and happy to welcome our speaker for the session now, Deep Learning in Real World Overview. So, Sir is working as Assistant Professor in the Department of Computer Applications, National Institute of Technology, Trichy. Previously, he was working as an Associate Professor in Belur Institute of Technology from 2006 for more than 14 years. Completed PhD degree from Anna University. He also Master of Engineering in Computer Science from Anna University, Chennai, and he has completed his Bachelor of Engineering from University of Madras. His research interests are machine learning, pattern recognition, advanced machine learning, neural networks, fuzzy clustering, soft computing, and deep learning. And we are privileged to hear from you, sir. Over to you, sir.
Thank you, madam. Thank you. Can you hear me, madam?
Yes, sir.
Shall I start my session?
Yes, sir.
Very good morning to one and all present here. This is Dr. Selvakumarti. So, Madam already gave enough introduction about me. So, there is no need of self-introduction. I hope so. So, straight away we'll go for the topic, Introduction to Deep Learning. This is my presentation outline. What we are going to discuss today. That is in my about what is deep learning, artificial intelligence, about machine learning. Then we will go for a brief discussion about deep learning and end up with the references. My session which is going to cover the complete information about deep learning. Before that, we'll go for some basic fundamentals of the topic deep learning, such as artificial intelligence and machine learning. But these two techniques or fields are supporting in this deep learning environment. Uh, First of all, we'll go for deep learning definition. Actually, the deep learning is a type of machine learning which is support to build a model to learn and perform a classification task directly from the image, that is set of images, text, and sound. We know it is nowadays we are challenging in handling of data, particularly images and a huge volume of text as well as sound from the internet sources. That is comes under big data. Here the deep is refers to the number of layers in the network. I don't know how many of you are aware of neural networks. Don't worry. So we'll go for step by step how this deep learning concept is developed and used in this current trend. I said this deep is mean for a number of layers. So the deep learning is a combination of learning technique with a neural network. This component of deep learning. So that is the neural network is that is the layers such as input layer, output layer. In between input and output layer, there's an hidden layer that is otherwise also called as a black box based of kind of thing. So we'll go for the evolution of deep learning. So while you're looking my slide, you'll get to know about how come this deep learning. So actually, that artificial intelligence is a field of computer science for designing and machines, that is any kind of softwares with an intelligent property. Later on, we'll go for a brief discussion about artificial intelligence and the various fields of AI, how it is imitating and everything. In the 1950s, that word artificial intelligence coined by John McKenzie. Thereafter, there is a conference regarding artificial intelligence in 1960s, and sooner the 1970s and 80s, they have closer to developing machines with an intelligence properties using Turing machine concepts and von Neumann concept and everything. And then in 1980s, the machine learning is coming to the picture, which is a subfield of artificial intelligence. That is a machine with a brain. That means how we can build a machine that will make an
Hello, sir.
intelligent decision. That's
Uh,
madam.
Sir, sorry to interrupt, sir. Do you want to share the screen, sir?
Yes, madam. No problem. We can share. Nothing problem.
Okay, sir. The third icon is screen share. So just click on it and you can share your screen. Or shall I do that, sir, for you?
Yeah, third icon. Just
Yes, sir. First,
okay. I know. Is it okay?
yes, sir. Yes, sir. You can proceed, sir.
Yeah. Um, so actually, I left out this machine learning topic. Machines with a mind. So how to make a machine with intelligence way of decision making without any human interaction. That means bringing automatic property, individual. That is even that is self decision making. Then the last one, that is that our topic, deep learning. Again, the subfield of machine learning. That means already I told you, the deep learning is a combination. That is integration of artificial intelligence and machine learning property. So the deep learning is breakthrough that of AI groups. That means it is going to incorporate neural networks along with that learning property. So we'll go for different types of neural networks. That is CNN, RNN. In generic, it is called as ANN. That is ANN is artificial neural network. CNN is convolution neural network. The last one is recurrent neural network. We'll go with one by one. This is the virtuous circle of deep learning. How come this? That is the initial stage of deep learning is AI, and it is slowly it is derived as a machine learning and followed by deep learning. So data user that becoming a great product. So in future, we'll expect a lot of deep learning based products. Even the previous session, Ms.Sarita listed out the various applications of AI and deep learning, everything. So this is a definition of artificial intelligence. Start results. Artificial intelligence is a branch of computer science. Aim of building machines or even software, the intelligence similar to us, so that it can perform like an thinking, reasoning, decision making, problem solving, and natural language processing like us. These are the four major categories of AI: thinking humanly, acting humanly, thinking rationally, and acting rationally. So that is while you are looking this content, is there any difference between the left hand side and right hand side? Sir, I think both are okay, same. Then you need, okay, just flip that word as rationally, rationally. So is there any difference? Obviously, there is a difference. Thinking and acting is okay. Humanly means like us. So most of them know how the human brain is processing an input through the various devices from there is eyes, ears, nose, even skin, everything, and we are taking action. At the right hand side, thinking rationally. That means rationally, rational properties mean for always making right decision. Even there is few cases the humans are in a one-sided, right? So suppose someone is favor to us, immediately we are following that them side and we are making judgments or supporting them blindly, right? But we cannot make such kind of machines in future or for making okay, good decisions. That is known as rational property. That means making the right decision and the right action. This is a small short form of history of AI. Already I told you that AI is the word term coined by John McCarthy in the year 1956. The aim of making computers or even softwares to do things and automatically, that is an intelligent manner. Developing an intelligent computers programs too. These are all the various class of artificial intelligence. Theorem proving, perception, robotics, natural language processing, common sense reasoning, expert system, and game playing. So and deep learning concept is going to combine all together along with the machine learning. So we'll go for touch all this, but due to the time constraint, I'm mainly focusing on deep learning because tomorrow, so my colleague Dr. Morgan is going to cover all the basic fundamentals of AI and its tools. And this diagram is going to depict the major dependencies of artificial intelligence. Such, the generic meaning of such, finding something or findings. Here in artificial intelligence, the searching is used for getting or finding optimal solution rather than the objective solution. The problem is n number of solutions. For example, that is swapping two numbers, without using third variable, with third variable, or otherwise can go for arithmetic manipulations like that. Similarly, the problem, real world problem has n number of solutions. Among the n number of solutions, how the machine can take or choose optimal solution, that is best solution. For that, the searching concept is come into the picture of the AI. There are three types of searching is involved. I think that is those who are already studied or handled for the their students. They get to know about that. Anyway, I'm going to list out here: uninformed search, informed search, and adversarial search. The uninformed search is otherwise also known as blind search. The informed search is otherwise also known as heuristic search, and the adversarial search, that last one is otherwise also known as game playing search. So there are some strategical measures we can apply and go for measuring the performance of these algorithms. Just a minute. Then the searching is followed by logic. Logic is meant for that indirect representation of information or otherwise knowledge. There is two different types of logics which are approached majorly in artificial intelligence: proportional logic, predicate logic. Otherwise, it is also known as first order logic. Even we can go for nth order logic, that is second order logic, like that. The proportional and first order logic, it's more than sufficient to represent or figure out our ideas. In knowledge representation, so we have to construct our entire information, that is input, knowledge, everything, that is reasoning, everything that become a knowledge. So for that, we are going to approach logic and everything. So machine learning, again, there are three major types of learning techniques. Later on, we'll go for a big discussion about those learning. Planning, I think you know what is meant by planning. There is a difference between planning and scheduling. So scheduling, already that is, we might have learned about that scheduling. There is a difference between planning and scheduling. In planning, it's an that is without time constraint. We'll go for sequence of action. In scheduling, with time constraint. This is the difference between planning and scheduling. So in planning, if the agent failed or supposed to face any failure, or it is not in a position to bring the solution, then it will go for plan B. That is like a plan A, plan B. So planning is the sequence of action that will reach from initial to goal state. That is known as planning. So that there is the bottom layer is advanced topics, NLP, vision, robotics, and expert systems. The NLP, that is natural language processing. That is, instead of learning computer languages such as C, C++, Java, etc., there's even up to Python, those things, we are going to teach our regional languages to machines. Through that, we can command and control the machines. That is an objective of natural language processing. Vision through the camera and the sensor interact and process the real world environment. And robotics, even the previous session, Sarita narrates about robotics in 2026. Robotics become going to dominating with us. The expert system is a part of artificial intelligence that is going to manage a specific or well-defined task. So it is going to cover the entire artificial intelligence. Anyway, I given just introduction about all this. These are the major dependencies of AI. So these are the three types of artificial intelligence: narrow, general intelligence, and super intelligence. The narrow intelligence is also known as weak AI. That means the particular artificial intelligence is going to focus on one narrow task. For example, coffee maker. The coffee maker can do only making coffee. Suppose if you are requesting that machine to prepare an biryani or chicken biryani, whatever it is not in a question to adapt and do. The second one is strong or otherwise general intelligence. It's actually this kind of there is an AI has the ability of performing that is general intelligent action. That means we know when we are in the childhood, we learned riding bicycle. With that experience, the situation forced us to ride a bike. Even we don't know about that various features of bike, we can ride, right? So such kind of machines. And then the last one is super intelligence, or otherwise it is also called as hypothetical agent. I think you might have seen the robot Hollywood movie, or here in Tamil Nadu the Endiran movie. So there is a robot Chetty. So like such kind of devices. That means robots, humanoid robots that will take only some 2 or 3 decades. It will come into the picture. And that is an super intelligence. It's an hypothetical one because it need a neural schema and everything. It's some tedious and things. These are all the major components of artificial intelligence. computer science already I told you the AI is in subfield of computer science. Psychology, that is that human psychology, we can imitate our human brain behaviors, how the human that is how the humans are thinking and acting. Neuron science, how to construct neurons and connecting those neurons together and passing the signals. Biology, again, we are studying the structure of neuron, right? Everything. Maths, there are few kind of mathematical notations we are going to be. Already I said the logics, proportional logic, first order logic. Even I'll go for statistics and everything. Sociology, right? A relationship and philosophy. While decision making, we want to give some justification for that. This machine must know about philosophy. So these are all the components of artificial intelligence. These are the major fields of artificial intelligence. While you are looking this diagram, you get to know about this. That is knowledge representation, planning, which we discussed, computer vision, reasoning, problem solving, robotics, NLP, social intelligence. You come to the machine learning. That's our next topic. So there are three major types of learnings fall under machine topic: supervised, unsupervised, and reinforcement learning. So these are the major classification of these three algorithms. So later on, we'll go for all these three algorithms in brief. So that's all about artificial intelligence. The machine learning is a part of artificial intelligence. So later we'll go for ML. That is short. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from the experience without any explicit programming or any input from the real world environment or that is uses. That means how to make a machine with a brain. That is known as machine learning. So the machine learning focusing on that is development of computer programs, that is algorithms, can access data and use it to learn for themselves. That means it don't require any human interaction. So that the result is automated machine. So the basic, that is the premise of machine learning is to build an algorithm that can receive, that is access the input data, applying the statistical analysis to perform a prediction of final results, and it is going to come up with new inferences, everything. You see this how the machine learning or what kind of concept is under the machine learning. There is a knowledge, it's a set of reasoning and some information. Based upon that, the system is going to take an action. It is going to compare with the real-time environment. Is it that action is good or optable or feasible or accepted by the real world environment? If it is okay, fine, then it is not going to do any modification in that knowledge. Suppose it is partially accepted by the real world environment, that is person or by people or user, then that knowledge is going to be updated. What kind of that is things they require, that is required in the future, or any corrections are required. In that way, the system is going to identify and correct itself and make a right decision. The final outcome become an optimal solution rather than the objective solution. So these are the types of machine learning. That is rote learning, induction learning, clustering, analogy, discovery, genetic algorithms, and reinforcement learning. Most of them are knowing about supervised, unsupervised, reinforcement. Anyway, all together is combined together as in these three. So, the first one is one-to-one mapping from inputs to stored representation. That's learning by memorization. That is association-based storage and retrieval. You know about association rule mining. I think you might have studied or even discussed with your students in the data mining topic. Induction, example-based. That is use specific examples to reach the general conclusion. Clustering and that is unsupervised learning category. That is a kind of grouping without using well-known labels or simply labels. That is natural groups. Analogy, that is determine the correspondence between the two different representations. Discovery, unsupervised, the specific goal not given. Genetic, that is evolutionary, the survival of fittest, you know. So here there are two important functionalities. That is crossover and mutation. Anyway, we are not going to touch all this. And the last one is reinforcement learning. That is based upon the feedback. This learning is going to either is going to reward or punish It's okay. It's by itself. That previous there is learning techniques are broadly categorized into three types: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the AI system is presented with a data which is labeled, which means each data tagged with a correct label. For example, you look at this diagram. You see this even there are a set of coin recognition. By the vending, there is vending machine, 10 rupees coin, 1 rupee coins, 5 rupees, even 25 rupees. You know, each coin has its features, weight, shape, even that is the emblem, that is even the logos, whatever it is accordingly. It is those features and all given. If those features are everything is available, then it is equal to 10 rupees coin, like that. So this kind of learning is called as supervised learning, or for otherwise there is the teacher and student environment. Teacher and student environment. So there is an interaction of among there is a student and then faculty. So this faculty can explain the concepts and everything. From their explanation, the students are learning and practicing. That is known as supervised learning. Even one more example, classification of emails. There are two types of emails. You know, there is a normal email and spam email. Suppose those normal and spam emails features are get trained by this system. So accordingly, that system is going to categorize the newly arrived emails, either it's in spam or not spam. You know the properties of spam mails, right? So you can feed those information to your machine, then it will learn and then perform the classification. That is grouping. So again, the types of supervised learning: classification and regression. Again, the classification is just fall under the supervised, which is with a label. That is going to be, for example, red color or blue color, or either disease or no disease, or male or female. Like that, it is going to be classified. For example, very good example for this classification is a decision tree, even SPM, Bayesian classifier, anything you can go for it. The decision tree mostly it is going to perform binary classifications. If you want to go for that is more than that, that is more than 2 class labels, then you have to go for fuzzy based classifications. Other thing. Next one is regression. Regression, again, the problem when the output variables is a real value, such as dollar or that means on a particular factor x is depends on y, or y is depends on x, that is vice versa. So linear, that is if for example height and weight, if that height get increased, even the weight also get increased. So either it is accordingly it may be an increase or decrease. That is known as linear. And a non-linear, again there are different types of methods that fall under non-linear regression. We are not going to discuss those things. Next, unsupervised learning without any well-known labels. We are going to process. That means the AI system is going to process the data and make its own group. So you look at this. That is the diagram. The left-hand side part is input data. There is some icons, that is duck and then other animals. So in this case, an unsupervised learning is going to identify all this there is animal pictures, and it is going there is pictures, and it is going to categorize all ducks together, Donald duck and what kind of ducks, everything. And then rest of the this rabbit and another one is in there's a separate group. So initially, this algorithm doesn't know what is it, either Donald duck or what kind of duck it is, or it's an a rabbit or whatever it is. But once it is going to process the data, then it is going to group based upon the similarity. You know about the clustering property, so it's a very good example for unsupervised learning. These are the two major types of unsupervised learning. Clustering actually, so it is fall under unsupervised learning. I said that is, it is going to grouping the data without any predefined labels based upon the similarity. So you know about the clustering property. There is within the group, the similarity is very high. Outside of the groups, the similarities it is very low. And association role mining, it is if the person is buying X, then what is the probability of buying Y? So you know about this association role mining and everything. And the next we'll go for reinforcement learning. The reinforcement learning algorithm or agent learns by interacting with its environment. Mainly, it is going to perform the two actions: punish and reward. If the agent perform or makes a right decision, then the particular sequence of actions that will be rewarded. That means that is adding some 50, some X amount of values or points. Suppose if the agent mistakenly did that is a wrong decision or it making a wrong decision, then that it is going to be punished. So it's a type of dynamic programming. It trains algorithms to make an reward and punish. For example, you see this. There's a robot. If the robot want to that is explore and navigate and explore to that is shut the fire or that is something has happened in that particular situation, that is a fire or it is want to control the fire, but without knowing anything, that is how to control the fire, and directly it is going to touch the fire and get affected, then it is called as punish. That means it not reach the goal. Suppose it takes a right decision for reaching the right hand, that is the tap side, and pouring the water, and then it will approach the fire place and taking care of that is yes, completing that risky process, then it became an reward. That is a sequence of action, whatever is taken by the agent is achieved goal. So first one observes and selecting the actions according to the policy, and corresponding action, that is based upon the perceipts, it will take the action and get the reward or penalty, that is punish. So update the policy. Suppose if the policy is achieving an optimal solution or maximum that is solution, that is utilization, then the next time also the agent is going to follow the same sequence of action. Fine. This is a summary of machine learning techniques which are discussed: supervised, unsupervised, reinforcement learning all together, along with its categorization and everything. So straight away we'll go for deep learning. Actually, the deep learning is a branch of machine learning. So already I told you. So which is completely based upon artificial neural networks. The neural network is imitating the human brain. That is along with deep learning. So also it's a kind of that is imitation of or mimicking of a human brain. Deep learning is there's no need to do any explicit programming like what you have discussed from the artificial intelligence. Even in the machine learning part, in artificial intelligence, you have to make an all the explicit, the reasons and everything in explicit form, make it as an KB, knowledge base. But here we don't need to go such an explicit form of programming and learning and everything, because the deep learning mechanism or algorithm has its own property of learning by itself based upon the features which is given in the input data. The concept of deep learning is it's not new. Also, it is an integration of AI and deep learning. The formal definition of deep learning is that is neurons. You know about the neurons. Even that is the basic unit of our human brain is neuron only. Even sir, that is 10 billions of or billions of neurons in our human brain. So this deep learning is otherwise also known as deep neural learning or deep neural networks. You see this a diagrammatic representation of our human brain. How that what is our human brain is doing this. That is auditory cortex, particularly in visually challenged people. How they are recognizing and this crossing or even passing the obstacles in the roadside, or they're in the path. So in the left hand side, you say, look at this. There is auditory cortex. That is this auditory cortex is going to learn from both the eyes and then ears. Sir, what will happen if there is that eyes is not okay? That is, the basic unit of our human brain is neuron only. Even that is the basic unit of our human brain is neuron. So this deep learning is otherwise also known as deep neural networks. You see this a diagrammatic representation of our human brain. How that what is our human brain is doing this. You see this a diagrammatic representation of our human brain. How that what is our human brain is doing this. working, or the physical, that is an, particularly that blind people. So they are going to use their ears and getting the sound. Based upon the sound, this auditory cortex is going to recognize and then make a decision, either any obstacles are there in there. So if this the persons are going to use some kind of sounds, about bat, the same concept is used by this visually challenged people. So if any, based upon the echo sound, they are going to identify any obstacles there in the, on the roadside or near to them. So such a way our brain is going to get trained based upon audio, even visual, touch, based upon the inputs from these input, that is sense. There's, you look at this human brain neurons. So this is the left hand side is biological neuron and the right hand side is artificial neuron. The left hand side, you see this the dendrites, this nucleus, soma, everything. The dendrites are used to interacting with the adjacent neurons. Then soma is body cell. In the even in this, the right hand side is that is the corner is axon terminal, that is going to process the signals from process the signal, or just forward the process signal to the next neuron. How our body is sensing all this. What are the chemical components which are used in our that is in our human body? Any idea? Because everything is based upon chemistry. We are using salt. You know that chemical name of the salt, NaCl, Na plus and Cl. That is a main thing that is used for transferring the signal from anywhere of our body part. Even if you are pinch your leg with an pin, automatically that pain is felt by your human brain without any delay. Suppose even you get any such kind of instant happen in your face area, but immediately the our brain is recognizing all the signals and make the action accordingly, right? So that's why, so our parents or even our friends are recommending us. Suppose we are not giving immediate response, add NaCl extra, like that. Just I'm kidding. Next one is the right hand side is there is artificial neuron. You look at this artificial neuron. There is an set of x, y, and that is the w. Where y is, there is all our mathematical notations. Don't get panic. Just I'm going to explain. Where y is an outcome, y equal to f is function of the multiplication of x1 and w1. Sir, what is w and x? X is an input. How much that is threshold, that value which you are going to pass through that node. While you are multiplying and sum all together, that is the first node x1, x2, and x3, and its corresponding weights respectively w1, w2, w3. Then summing all together. Sir, what is meant by function? Any function you can go for it according to your application. Whether sigmoidal function, Gaussian function, or any function you can apply. So you have to choose the functions based upon your environment or through the experts, domain experts. You have to choose. So based upon that function only, you will get the accuracy. So the f of x equal to the maximum of 0 or x. So with that y, that is that particular y neuron is going to fire or not. So if that values are greater than or equal to that you are fixed, that is a value, then the neuron is going to get fired. And this is a difference, major difference between machine learning and deep learning. So that is why we have to go for that is deep learning. Works on small amount of data for the accuracy in machine learning. But the deep learning, always we are focusing on a large amount of data, that is big data. So it is hectic to manage. That is a huge volume of data using machine learning. That machine learning is dependent on low-end machines. Because we are going to processing small amount of data. But here in deep learning, we need an high-end configuration machines like GPUs and other supercomputers. Even that is high-end machines, that are RAM and other that is processing machines. And divide the task into subtasks, solve them individually, and finally combine the results in the machine learning part. That is divide and conquer method. But in the right hand side, there is deep learning, solve the problems end to end. There is no dividing the whole task into subtask and combined together in the end. And that machine learning part, it takes less time to train, because the reason why is data set is very small. And in this deep learning part, we are going to dealing with a huge volume of data. So if the volume of the data is more, obviously it will take too much of training time. But we will expect a good, there is an acceptable rate of results. And the testing time may increases in the machine learning part. In the deep learning part, it is less time to test the data, because it is trained completely with a huge volume of data. Most probably all combination of data so available. So with that we can train and we'll get the efficient things. So trend changing, that is, if you are approaching machine learning again, we are getting an poor accuracy when we are not in a position to manage a huge volume of data. It's like an old crow, that story. So if you will go by deep learning, so you can get our results in a much easier way and also in an accurate way. That is like a modern crow. Instead of collecting the stones and keep it one by one, we'll use the straw and then you can add the water. Next, we'll go for deep learning. This is an architecture of deep learning, because we already discussed about the definition of deep learning. So straight away, we'll go for the architecture of deep learning. So in this topic, we'll go for a discussion about what's meant by artificial neural networks, how the neurons are firing, how to set a threshold, and what is meant by perceptron. What are the four major components of perceptrons? Um, we'll go for forward propagation, backward propagation, fully connected layers, convolutional, recurrent RNN, recurrent neural networks, everything one by one. So, that is the main idea of this deep learning is we are imitating a human brain. That is, it's going to focusing on one learning algorithm through multiple combination of inputs, and building that algorithm in a much efficient way by its own. That means without any user interaction. So most of the human intelligence may be due to one learning algorithm, because I think you know the difference between human brain and a computer. Our human brains are massively parallel. I think you know what is meant by massively parallel. For example, we can manage and perform more than one task at a time. That is multitasking. That is why we are looking our students, or even during our class timing, we can monitor our students, and also we can write the notes and notes on the board. At the same time, we can dictate this. We dictate it the same to the students, like that. At the same time, our hands are going to discuss what concept we want to narrate, or that is we are moving our hand, that is hands front and forth, and we are it is making that particular image which there is an imaginary form, and we are also walking in our own this classroom. So there is massively parallel, but the computers are massively serial. That's why we are lagging in there is mathematical viewpoint. Suppose if some 10 cross 10 digits, even multiplier and multiplier both are 10 digits, it's very difficult to do the multiplication. But the machines are much faster, because it's a serial. That is the difference. A main difference between human brain and computers. But human brains are okay, enormous computing power, and dealing with the parallelism, everything, real-time decision making. But the systems are much, even though much faster, but it is not in a position to handling real-time problems because of the lagging of that parallelism. So now we'll expect those kind of machines based upon this deep learning techniques. So I mentioned about one learning algorithm. So through all the sensors, that is eyes, ears, that is going to get trained, that is the human brain, what it is, even some symbolic representation and everything. This is a neuron in our human brain. You know, as already I told you, billions of neuron is combined together and processing the signals. That's why we are done that, such an that is parallelisms. You look at this artificial neurons. The first one is the left-hand side top corner, A to B, a single neuron, where A is an input neuron and B is an output neuron. In between this, A is multiplied with weight of W, and where B equal to W into A. the top right hand side, you see this, there are the two inputs are connected with this neuron. Then the output y is based upon this x1 and x2, where x1 is multiplied by 1 and x2 is also multiplied by 1. So where y equal to x1 into 1 plus x2 into 1. So this is a mathematical representation of this neuron functioning. Even you see this bottom side, left hand side bottom corner, so how the y is calculated, even based upon this bottom, there is a left hand side bottom corner. Similarly, that right hand side, there is an n number of neurons which are connecting with this y. So this is a specific neuron behavior. How the neuron is performing an action, you see, where z equal to summation of I equal to 1 to n. It is w of I into x of y, that is equal to output. That is, if that value is greater than or equal to that h of z, that particular neuron is going to fire. That means on. Sir, what will happen if that value is lesser than that defined threshold? Then that the neuron won't fire. That means switch. That is, it's kind of a switch on off. So these are all the various that is mathematical representation of that neurons. Y equal to f of x comma w, where y is an output function, where f is representing function. Any functions like an sigmoidal, Gaussian, which already told you. And these are all the a few other models of field, retropropagation. Even any idea about hidden Markov model? Hidden Markov model, HMM. That is also okay, and a kind of an neural network model. It's a statistical based model. You can go for it applying statistical or even fuzzy, whatever it is, according to your application or environment. There's an logical neurons according to the finite automata. So, and you know about the function of okay, and gate or and logic. If both inputs are high, then only that particular output is equal to 1. So, for you see, if both okay inputs are 1 1, for example x1 and x2, 1 into 1, again 1 into 1, so 1 plus 1, it is equal to 2. So 2 is greater than 1.5, so this particular neuron is going to fire. That means on. You come to this R, any one neuron is high, then that input, that is output equal to high. So for example x1 is 1, then x2 is 0, so 1 into 1, 0 into 1, 0 plus 1 is 1, so 1 is greater than 5. So similarly, there is NOT gate, it is flipping, that is inward, there is an inward value. If it is 0, then it is 1, or 1 0. For example, if it is 0 means 0 into 0, then it is 0. It will, okay, because it's an that is less than or equal to 0, so it is going to be enabled. Suppose any positive value 1 into minus 1, again this value is lesser than 0, so it is not going to fire. So I think might have some idea about how these neurons are fired. This is a simple structure of artificial neural networks. And this left hand side, a set of neurons that is known as the input layer. At the right hand side, and output layers. Sorry, that is yes, output layer. It is an only single node. In between an input and output layer, there is an hidden layers. So there is an basic structure of artificial neural network, ANN. The input layer processing information and fed forward the result to the hidden layer. Actually, the hidden layer is a kind of black box approach. That means we don't know what will happen, how those nodes are processing, but we will get the results. Generally, there is a concept. We cannot exactly identify what it is going on in the in depth of that hidden layer, but we can define how many number of hidden layers we want to keep and how many number of nodes in each layer, everything. So later on we'll discuss that numbers and everything. So the objective of the neural network is to transform the input into a meaningful or understandable form of outputs. So these are the various applications of artificial neural networks. Controlling the movement of robots, that is based upon HSL perception and other information, there is visual information and even the sensor, there is a distance measures, sonar and everything, there is sensors, everything. And deciding the category of potential food items, either it's an edible or non edible, like that in the artificial world. There is categorization, even grouping, and recognizing the visual objects that is even instead of using biometrics, they're going for capturing the video. Based upon the videos, they are recognizing whether the person is present or not. So attendance, that is role cast of students or even employee, there is attendance management, everything. Predicting where okay, the moving object goes. That is, when the robot wants to catch that particular thing, or even all these concepts are applicable in game playing environment. Again, we'll go for mathematical representation of neural network. You look at this. Again, you don't get panic while you're looking the mathematics. You see this, that input layer, that is where y, that is the superscript of 1 is represent layer 1. That means first level. And then the subscript represent that node numbers 1, 2, 3, 4. There are 4 nodes in the first layer. So that superscript numerical value represent the layer value, and the subscript represent the neuron number 1, 2, 3, 4. So you see how this single neuron is going to perform computation. Where again similarly W of 1 is, that is that superscript represent the weight value in the level 1, and is the first node weight value, or otherwise simply you can keep it as W1, W2, W3, W4. And that outcome of this particular node is y of 1 comma 1, that is equal to, is going to process that weight along with this input value. Similarly, this layer 2, that is a hidden layer, you see this layer 2. Actually, the layer 2 is going to process the input as from the previous layer 1 comma, that is 1, 2, 3, 4, everything together, that is y of 1. So that information is here. You see this. Actually, the connectivity is based upon mesh connection. I think you know about that graph representations, how the nodes are connecting like that, fully connected like that. So it is fully connected because all nodes are connecting with other rest of the nodes from the excuse me, that's the next level. So y2 of 1 equal to function of y of 1. That means y of 1 means, how come all this, and it's weight of this particular node. So finally, similarly, it is going to be calculated by y of 2, y of 3 in the second layer, and all together the 3 node values are going to be processed in the output layer. So that is y3 altogether is become a function of weight of that is y3, that is y2, and the multiplication of weight value. So this is a mathematical representation. It's very simple. And you see this generic representation of this what we have discussed from the previous slide. So y output equal to the function of x, where x is an input, w is the weight matrix. Even it is also the weight vector. You know about the vector. Energy, you know about the energy is measure of the task performance error. That's the difference. How much we are providing as an input and what we are receiving in the output. In between the input and output, how much difference is an energy level. So we are going to fix it as that much as an energy to our. You look at this perceptron. How this perceptron is working. And this neural network. Perceptron is a single layer neural network. Single layer means how it is, because we have discussed about 3 minimum layers: input layer, output layer, even in between input and output layer. Single layer means only one layer that is going to process and you will get the result. A single layer, it seems, either input alone that become an so neural network, and you see multi-layer perceptron is called neural network. That means if that is the network has input layer, output layer, in between input layer and output layer, there is a 10 layer, then only you can call it as full neural network or multi-layer perceptron neural network, or simply neural networks. Otherwise, it's a single layer means only a specific set of neurons. Here, the perceptron is actually a linear classifier, that is binary, either 0 or 1. That means either the particular output is 1 or 0. It is used in supervised learning. You look at this GIF file. There are 2 inputs that is labeled as cat and dog. So this neural network is get trained to identify either dog or cat. That means it is going to process this and finally it is identify cat. Suppose that both the images are dog, then it is going to say 0. That means no cat. That's it. These are the 4 major parts of perceptron. you see this, there are four major components of each neurons. They don't think about the layers, multiple layers. One single neuron, it seems, it has all these four parts. Input values or input layer, then weight and or otherwise that is bias, that weight and then the next sum calculation, the next one is active or activation function. So even I told you in the previous slide, it seems some input values that is going to be multiplied with this weight value. Finally, it is going to sum together and it is going to compare with this activation function, that is the energy value. Even in the previous slide, we have discussed about how to set this energy value, difference between input and output value. We have to fix it that okay value. If our value, that is the sum value is greater than or equal to this activation function, then this neuron is going to fire. That means on and process the signal and pass the signal to the next neuron. Otherwise, it won't. So this is four major parts of a perceptron. So each neuron has okay all these four parts, and it is going to function by its own. So how this perceptrons are working? These are the three steps. All the inputs x are multiplied with x. Okay, their weights w. That is where k, that is called as that is called as k, where k equal to x into w. And add all the multiple values. There is summation with this weighted sum. Apply the weighted sum to the correct activation function. So these diagrams are depict this. There is x1 into w1, x2 into w2, and so on. The second one, adding this. Suppose there are the five weight values where k equal to 1 to 5. So that value is going to be summed and it is going to be compared. If the value is greater than the activation function, then it is going to switch on. Otherwise, 0. So we look at this on example, how this neural network is going to identify whether the given image is bright or dark. So there are 4 pixels it is going to be processed. That means here you see this, there are 2 layers, input layer and directly output layer. There is no it is even single layer, it seems, input and output layer. X1, X2, X3 and X4 and its corresponding weight values. All pixels has equal weight. So if you are multiplying, that is 1, 1, 1, 1 each value, that is 1, 2, 3, 4 according to the pixel values. You see pixel 1, 0.25 into 1. Again the pixel 2, 2 into 0.25. So you will get the result. Obviously it is greater than minus 0.1. So it is going to conclude the given image is bright. So next we'll go for again about the neural networks. So already we have discussed enough information about, because this slide is going to summarize the previously discussed information. So the neural network is 3 layers: input, output, and hidden. And it is going to focus on that is nodes, that is hidden nodes. This actually the hidden nodes, which is depends upon the hidden layer nodes depends upon the number of that means in between the number of input nodes and then output nodes. For example, your input data has some 10 features. Okay, 10 features. 10. Your result class labels are 2. So in your neural networks, number of input nodes equal to 10 and output nodes equal to 2. Sir, how shall we fix the hidden layer nodes, or number of nodes or number of layers? Again, the number of layers that is depends upon the experts recommendation, and the number of nodes in the hidden layer is in between that value 10 and 2. Sir, shall we keep 3 nodes? Yeah, you can keep it. Sir, up to 10 you can keep 3, 4, 5, 6, 7 and so on up to 10. Sir, what will happen if more than 10 nodes? That is not okay. So based upon the trial and error method, we have to fix it. How many number of nodes we want to keep? But the range value is in between your input node. There is number of input nodes and the number of output nodes. So in such a way, you have to keep or set the number of nodes in the hidden layers. Actually, this is a procedure. This is again the pictorial representation of neural networks. It's a multiple hidden layers. So shall we keep n number of hidden layers? Yes, we can. So if we will keep in such a way a number of hidden layers, then it become a deep learning. So we'll go for one more concepts based upon neural networks. Forward propagation. That means the current layer result is fed forwarded to input of that is known as feed forward. So this while you are looking this diagram, you'll get to know about this. Otherwise, also known as forward probe or simply forward propagation. Next one is the backward propagation. So it is required and labeled data. Then only you can do all this kind of backward propagation. It is the weights and bias are it is slightly until the lowest possible cost is achieved. Okay. There's an some difference between backward propagation and forward. Forward is from the current layer to the next layer. The backward is just it is going to be revert. And something difficult in this backward propagation is required a lot of label training. But in our real-time scenario, almost all the data is unlabeled, and then it required a learning time is did not scale well because you have to forward back and get trained. So very slow in networking. So got stuck a local optima, because we are dividing and doing the work separately and combined together. It's very difficult. Next, we'll go for deep belief network. I think you know about Bayesian belief network or Bayesian classifier. Like similarly, this one also going to have the same concept, but the term is deep. That means multiple layers. While you are looking, look at this diagram. There is an H1, H2, H3. That means where H1, H2, H3 indicates hidden layers. That is multi-layer architecture. That's why it is called as a deep belief network. That is, you see this, it is used by the Google for recognizing the images. Even this deep belief network is here it is trained with the 2 layers at a time, and it's similar to the restricted Boltzmann machines. That means it's a constant and some mathematical notations involved here to defining some perception values, everything. Don't get panic about this RBM, restricted Boltzmann machines. Please, you have to learn some fundamental mathematics about that is equations, polynomial equations, and some Gaussian falsifiers and some equations like that. Then only so you will construct your own networks. Anyway, so there are a lot of tools are there. Later on, we will discuss about those tools. How do we construct or design our own deep neural networks, everything. Next, some advantages and even something. There is some important things we are going to discuss about a deep belief network. Actually, the deep belief network is ability of recognizing that inherent that is patterns in the data. That means even this belief networks has the ability to extract, that is infer the hidden informations or results or data from the training set. It's a sophisticated and the multi-layer feature extractor, so that only it can extract the hidden patterns. And also it has a unique aspect of this type of there is a extraction things. So we'll get the full input structures. That means we can go for input and multiple number of hidden layers and followed by output layer. So each layer it is going to extract some features based upon the input is values given. And also even it is useful for image based facial recognition and everything. And then this belief networks are learns hidden patterns globally, even through the cameras. The images are captured in real time, then it is going to be processed. And also it requires a set of labels to apply the resulting patterns, because it doesn't back probe approach, so it needed a few labeled examples for training purpose. And we'll go for inside the deep neural networks. Inside the deep neural networks, actually they combine multiple non-linear processing layers already mentioned. There's a difference between a deep neural network and a normal neural network. Deep neural networks, it has an n number of hidden layers. While looking this, you'll get to know about the difference between deep neural networks and a normal neural network. Neural network has only a restricted number of hidden layers. In deep neural networks, n number of that is hidden layers. Right here, you see this. The layers are interconnected nodes, neurons, with this. Okay, each okay, from one hidden layer to another hidden layer. Next, we'll go for how this deep neural networks are learns. You can say there is, let's say there is the images input. You see this, there is a set of convolutions. There are two major parts of this neural deep learning. There is deep neural networks. There is convolution part and classification part. Later on, we'll go for brief discussion about that. Here you see this, the convolution, that is rectified linear units, pooling and other things. That is, you know about the pool, just it is going to process the data. So using this training data, it is going to that is recognize all the features without any human interaction. That means automatically it is going to process the features of data, no matter that is the input, whatever the input data will be given. And each layer in the network, it takes the data from the previous layer. That is, I told you, excuse me, that one, there is the first layer, is ith layer output is fed forward to the input of I plus one layer. Excuse me. The network has increased the complexity because of there is number of nodes from the each layer, and definitely we'll get the accurate results. For example, the right hand side you see this, the image is an input. There is an input image is an flower. It is going to identify the there is number of features from this particular image. It is going to recognize how it is going to be. So this slide, it will show you how the deep neural networks are functioning. So the first one is the raw input that is going to be processed through this hidden layers. So the hidden layers are dealing with a set of features already said, low level features. That means ridges of our face, regions and everything. And middle level features, you know about face parts, that is a mouth, that is mouth, excuse me, nose, eyebrow structure and everything, even hair color, etc. Then high level features, it is going to represent our face structure, either V shape, otherwise round shape like that. It is going to identify each hidden layer is going to taking care of a particular features. So it will exactly identify the correct. This CNN is convolutional neural network. Actually, that term is convolution is mean for irregular ridges of our human brain. So that only this name is okay represented here. It seems the convolutional neural network. Actually, it is inspired by this visual. There is visual cortex. So while you are looking how the images will get processed, the same principle is applied to this neural network. Actually, the CNNs are deep nets that are used for images, objects, and even speech sound. Because these are all the major data in the current situation that became an that is big data. So this this is invented by Jan LeCun. Deep supervised neural networks are generally such too difficult to train them. You know, because each hidden layer has a set of neurons and it's going to process huge volume of that features and everything. So then, okay, obviously the CNN also is in multiple types of layers, right? We look at this diagrammatic representation of that convolutional neural networks. Here you see this the filter of two. Here that the color that is dots indicates the filters. A series of filters forms a layer. That is you see this, that is a set of filters, that is red color. Okay, that is layer. That is it is going to taking care of some medium level features. That blue color that is, filters are going to take care of low level features. The green color is going to taking care of high level features like that. The weight values and it is going to be. And also it is going to perform a sequential form. Excuse me. And it is going to process and flashing the single okay neuron. You know how that neuron is going to get fired, which already discussed. So it is going to process the features along with the weight values, and it is going to predict the results. Again, it is the brief representation of CNN. So it has an two major part, the spooling and convolutional part. That is, we will discuss in brief. So the first one is feature detection layer, and the next one is classification layer. So look at this, the diagrammatic representation of convolution neural network. Actually, the convolution neural network is set of hidden layers. You look at this feature detection. So input, after that it's an feature detection layer, the convolution part, and you see this rectified linear units that is going to perform the process of training, that is mapping the negative values to zero and maintaining only positive values. You know about upper triangle and lower triangle, right? In an upper triangle, there is upper part is an non-zero values and lower part is zero values. I hope so. Similarly, this rectified linear unit is going to taking care of all this. Please don't get panic about sir, how do we construct all this, because nowadays there are a lot of tools are available. Even in MATLAB, there is a specific tool is there, so you can use it. Or otherwise, if you are very strong in R programming, you can go for it. So end of this presentation, I'm going to recommend a few set of things how it is going to be. Then pooling, here you see this convolution part. Already mentioned, put the input images through a set of convolution filters, each of which that is activates certain features from the images. Already say low, that is low level features, high level features, even medium level features. Pooling is simply simplifies the output by performing the non-linear downsampling. You know about the downsampling, that is reducing the number of parameters that the network needs to learn about. It is not going for, that is a kind of reduction technique, pooling. And we already discussed about the rectified linear units. And these three components or operations are all together is become a feature detection layer. The next one is classification. I will discuss from the next slide. After the feature detection, so the CNN is going to apply this classification layer. This is an fully connected layer. You know about that fully connected means each node in that particular, that is every node in the previous layer is going to connected with a specific node of the current layer. That means, for example, three nodes are in the hidden layer. Then the three nodes all together is connected with first node, second node, third node, everything. That is known as fully connected. So where that is, it has an k dimensions. So where the k is the number of classes. That means how many number of class labels are there. For example, it's a male face or female face, or otherwise any other combination like that. So the final layer of this particular convolutional neural network is the softmax function. Actually, that provides the classification output. That is the purpose of softmax. Even if you want to explore this, explore this architecture, just you can click this. I don't know how to share the screen. Sharing the screen. Okay, no problem. Right. And the next one is recurrent neural network. It's an advanced concept of this deep learning. Recurrent is mean for a repeated learning, that is iterations. That's why it is called as recurrent neural network. Recurrent neural network actually that is produced by this Jigsaw et al. Actually, this recurrent neural network as a feedback loop. We look at this the diagrammatic representation of this recurrent neural network. So it is actually output is fed back to the into the net along with the next input. So that's why it is called as feedback loop. Even it is similar to hidden Markov model. Even in the hidden Markov model, there is a forward and backward approach. This is similar to backward. Actually, this RNNs is an input and produce an output, unlike other nets. Even this, it is the variation of RNNs. LSTM, these are latest technologies, long-term short memory. Most of the researchers are that is approaching this for a recent research topic. The next one is working procedure of deep learning. How do we construct our working procedure? That is neural networks. The first step is understand the problem and check the feasibility of deep learning, whether possibility of applying deep learning or even the neural network is sufficient to solve the problem. Even the particularly neural networks, deep neural networks, deep learning approach, either RNN is sufficient or CNN is sufficient. What kind of input are you going to process? So identify everything. Then you have to go for perform data processing. There, I think there is extract features, there is feature extraction, and class labels. What are the results? Are you expecting those things? And you know about this. Most of the data mining concepts are coming into the picture. The noise removal, etc. Choose the deep learning algorithms, which I mentioned already. Either RNN is required, CNN is required, or supervised learning is required, unsupervised learning is required, or reinforcement is required, and then go for training the algorithm. That is one algorithm training, and then test the models based upon the models performance according to the training data set or otherwise your data. So this is an deployment cycle of the deep learning. You see this, the data scientist going to recommend a set of data from the network, then features and everything, whatever it is, and based upon this, it is going to be constructed a model. You see this, whether either classification, detection, or segmentation for this. And it is going to be processed with this real-time data, and the feedback is goes back to this development. Again, any enhancement is required for that. So this is a deep learning deployment cycle. Then these are all the advantages of deep learning. Actually, the best in class performance on real-time problem, and also it reduces need for feature engineering. That means we don't need to break our head to extracting features and what kind of data we want to define. I think you know the types of data: ordinal data, the continuous data, discrete data, nominal data, binary, like that. So whatever it is going to train. Only we have to define the number of hidden layers and everything, and also eliminate the unnecessary costs and everything, and also identifies defects easily that are difficult to detect by manually. These are some disadvantages. Large amount of data required. Even I told you about big data, and the computationally expensive to train because it takes too much of training time for computing the features and everything. And also, you see, no strong theoretical foundations. Even previously, I told you about hidden layer representations. It's a kind of black box testing process. We don't know how those hidden layers are working, but we are feeling that how it is working. It's like an operating remote, okay? Operating any that is electronic device through remote. That is a kind of black box testing. Inside how they are defined circuits are functional, we don't know. While we are pressing the button, we feel the particular functions, and also require a good understanding of how these models are model multiple modalities with the traditional tools and everything. These are the disadvantages. And then these are the various deep learning applications, internet and cloud platforms, speech recognition, language translation, language processing, sentiment analysis, recommendation. Even the first session, Ms. Sarita said about personalization. Even there is automatic, there is driverless cars, everything. So that is combined together this deep learning with the internet, cloud, everything. Then medicine and biology, know that the 3D printers is coming to the picture. Just I'm going to summarize what ma'am said about advanced concepts of this 3D printing, cancer cell detection, diabetic creating, and even human organ. That is artificial manufacturing of human organs and everything. Even in media and entertainment, just video capitalization, video search, and real-time translation and everything. And also mainly how to focusing on security and defense, even cyber security and everything. We'll go for more research in this area. Then autonomous machines, that means without any human interaction. So that is automated car, even Google cycle, everything. Soon we'll expect all those kind of applications based upon the deep learning. Again, these are all the very specific deep learning applications, uh, right? And started with the deep learning. Just you can go for get the data, construct an net. Some of the examples are there. That is an built-in nets, AlexNet, even Google Net, like that. We'll go for even how to do this. Uh, Ma'am, how can I share my screen? Madam, how can I share my
Uh, so,
screen?
the, so the third
Uh,
icon, and you just go for entire
okay,
image.
okay.
You can see the image and
Okay,
click on
okay,
it,
madam.
sir. You
Then
can
fine,
share your
fine, madam.
desktop.
Then fine. Okay, it's okay, no problem. These are only some platforms regarding there is deep new okay deep learning. Please you refer this platforms, even frameworks, libraries, and everything. These are all the examples. Keep well defined deep learning approach. AlexNet, Google Net, FastNet, etc. So these are all the some URLs for trained models. We don't need to go for training. So the more deep learning resources, that is MATLAB is suitable. Even you can go for R programming and everything. Before I'll go for there is a questionnaire section. Just I'm going to show one video clip how this deep learning is going to be in the future.
So is that possible for you, or I will share that video?
I'm going to share it, ma'am. No problem. Hmm?
Okay, sir. Uh, Sir, we can't hear the video sound, sir. Check out whether it is in mute, sir. Video sound. Yes.
Okay, madam. Any questions, madam?
Yes, sir.
Yes, madam.
Is image processing based feature extraction? Is there any minimum data set that is required? Minimum data set
If you
required.
go for deep learning, you need an big data, madam. For example, if you go for real-time, even road crashing, and then if suppose you are tracking signboards in the road, your okay vehicle is moving, so every time that is it is going to for a fraction of second it will get more data frame, right? So obviously you'll get big data only. So we cannot restrict. Minimum means a kind of MB data is required. That alone you'll go for it, madam. But the accuracy viewpoint we have to think about it. If more data, we'll get more accuracy. That means training data set.
Yes, sir. And we have clustering a priori and algorithms in AI. And is there
Yes,
any
madam.
algorithms is specialized for deep learning?
Madam, classification, we can go further. You said about clustering is unsupervised category, even association also unsupervised. Supervised learning, we have discussed about so many things, SVM, there is a Bayesian classifier, decision tree, random forest, etc. So according to your that is application, for example, if your data set is medical diagnosis data for prediction of cancer like that, either are you going to predict either the class label is yes or no. In that case, we can go for classification. Right, you know that is that more accuracy is very much important. If even the 99% your prediction is right, 1% is goes wrong also, your algorithm is not suitable in this medical domain environment. Except that you can go for selecting the there is learning technique according to the environment, even supervised or unsupervised.
So
Uh,
how to
uh,
select the weight factors? How to
Yes,
select
madam.
the weight factors?
Yeah, yes, madam. That is an okay, very good question. In the weight factor, you ought to that is first. We'll go for a trial and error method if you are not aware of your data set very well. That is trial and error method. Initially, you have to go for zero first, and then point. There is numerical figures and range. Before that, you have to that is refer that data set. What is that value? It is either continuous, discrete, like that, and you apply statistical measures. Even SPSS is there. Even stat plus is there. You can analyze your data before you go for training. You'll get to know about that. Okay, each features average or anything, mean values, and then you can proceed. Man. That is the only factor to set the weight values.
Yes, sir. So we'll take up one more question.
Sure, madam.
How optimum number of layers can be fixed? How optimal number of
Uh,
layers
Again, there is
for
that you are.
fixing
I
data?
think you are asking about the number of hidden layers. I hope so.
Yes, sir.
Right?
Yes, sir.
Already that is again it is also we can go with two viewpoint. One is again trial and error method, or otherwise exports, domain exports. Based upon the domain exports suggestion, how many layers we want to put, or otherwise we have to go that is by a trial and error method. We'll keep for example 10 hidden layers, and either you can increase or decrease the number of layers, and will verify the performance, either it is again the others remain constant or any changes. If there is no changes happen in that output part, then you have to don't disturb that number of hidden layers for either increasing or decreasing, right?
Yes, sir. So,
Any other queries, madam?
uh, yes, sir. We have one more.
Tell me, madam.
Yes, sir. Is image processing based feature extraction is effective in quality control?
Yes, madam. Yes, madam. We will go for it. We capture the image and we'll process the features of that particular image, and we'll go with okay. Go for real time quality that is an industry based products, madam. Even without any human interaction, while capturing the video or internal part of that particular product, everything will identify the defects.
Yes, sir.
Sure, madam. We will
And
go for it.
since we have participants from different field like commerce, botany,
Okay.
mechanical, electronics, communication engineering, they need some useful websites for future upgradation regarding this topic.
Hmm. Sure,
If
madam.
you, yes, sir. If you share
Okay.
to me, I will just, yes, sir.
Madam, already I
Share
sent the
to me.
PPT here. You see this, madam. There is two links given. This is for already trained neural networks by the AlexNet and GoogleNet, FastNet. That is for
Yes,
image, text, even language based. Apart from that, you see this MATLABs, R programming, anything that is the data set is any okay domain, irrespective of domains. You can apply this MATLAB, R programming, even built-in tools, anything. Even sorry, TensorFlow, it is available, madam. You can.
yes, sir. Thank you very much, sir. Thank you. On behalf of Chennai Institute of Technology, we thank you for spending your valuable time for us. And we definitely got an overview of deep learning and how to begin with that deep learning topic. And in future session, we have hands-on in deep learning on day 4 5. So thank you, participants, and thank you, sir. And we are happy to connect even in future with you. Thank you, sir.
Thank you. Thank you, Ananta. Thank you.
Thank you. And participants, you can join the same link, join the afternoon session using the same link, and the attendance link will be shared to you in the afternoon session. And you can use the same link to join for the day 1, session 2. Thank you.